The theory of everything has been found. Hello, my name is Harris Hamatopoulos, and I have found the theory of everything. This is part 4 Cosmology, and we're going to see how the universe really started. Not with a big bang, but with a big collision. We're going to see why stars and galaxies rotate the way they do, and it's not dark matter, because there's no such thing as dark matter. I'm going to tell you about something more dangerous than black holes, pockets in the universe where there is no universe. I'm going to also tell you about how at one point we had an expanding and a static universe at the same time, and lots more. We really don't have any way to describe it, because our experience is that there is something in something else. People that believe in the Big Bang Theory believe that space started at that point, and before that space did not exist. They say that the universe is expanding, and space itself is expanding. If you believe that, then you're an idiot. Space has no dimensions. It's not a substance. It's not something that exists. You can't create it. There is no analogy that you can use to describe it. Space is endless. There is no beginning, there is no end. Space doesn't exist, so how can it start to exist at the Big Bang? You need to move away from thinking that space is something. The best way I can describe it is that space is nothing. Our universe is something. It is the opposite of nothing. The ultimate question isn't how the universe started or how it will end, but where did the matter for the universe come from if space is nothing? The universe is a finite physical three-dimensional field, so it is an object in space that has a size. There is space in the field and outside of the field, so the field has an end. The field is made from two objects, physical lines that have mass, and the smallest particle in the universe that I call the quantum particle. The lines are millions of light years in length. However, they have a diameter that is less than the radius of an electron, so they are incredibly thin and incredibly long. The lines are flexible. They are fully elastic and are indestructible. The next object, the quantum particle, also has mass. It is the smallest and most numerous object in the universe. Its diameter is the same as the diameter of a line. Its energy is kinetic, its collisions are perfectly elastic, and it is also indestructible. The energy of the universe is the elastic kinetic ability of the quantum particle. The combination of quantum particles and lines form a three-dimensional field structure. Lines are orientated in 3 dimensions. Parallel lines are separated by lines orientated in a 90-degree direction. The lines are not in contact with each other. What keeps them separated is the quantum particles bouncing between lines. Quantum particles bouncing between 2 field lines will impart their kinetic energy to the lines. This acts as a repulsive force, pushing the lines apart. However, when we add more lines, a counterforce is created, preventing lines from moving. This equalizes energy. The field lines prevent the quantum particles from escaping the field. This conserves energy in the field. The lines not in contact with each other allows the quantum particles to move around the field freely. This prevents a buildup of quantum particles in any location, allowing for quantum particles to be evenly spaced in the field. Therefore, the field is a homogeneous system. This leads to an isotropic universe. The universe began when 2 giant, very fast-moving fields collided. The initial field lines collided along a plane orthogonal to the direction of the oncoming fields. Field lines from both fields are compressed together along this plane. The result of this is that matter we are familiar with was created along a vast plane. The field underwent multiple collisions and expansions. The collisions would involve multiple field lines. These lines would be compressed into a band. This compression creates extreme energy pressure in the center of the band, which then pushes the lines as a band back in the direction they came from, faster than the speed of light. Therefore, there is a massive expansion until the next collision with the next oncoming field lines, which then creates more bands. The bands have a higher energy density because the field lines in these bands are closer together. When the bands are pushed back in the direction they came from, a lower energy density is created in the field because the lines here are wider apart. This process repeats along the field, so the field develops bands where the field lines are closer together with higher energy, and in between these bands, lines are further apart with lower energy. The field undergoes this process of collision and rapid expansion until the last field lines collide. These rapid expansions sound like cosmic inflation. However, inflation was invented to solve the horizon problem and the flatness problem of the Big Bang. My theory does not have these problems because the field prior to the collisions is highly homogenic. So any part of the field that undergoes a compression will create the same particles and radiation, therefore have the same heat. My field before the collisions is a three-dimensional flat field with zero curvature, and it remains that way after the collisions. Outside of the field there is no counterforce, so the repulsive force of the quantum particle will push the outermost field lines off into space at the speed of light. Consecutive lines move off but at a progressively slower speed. This results in an accelerating expansion. The consequence of this is that the energy in the universe is weakening because there is an expanding distance between the lines. Eventually, the entire field will move off into space and the universe will end not with a bang, but with a whimper. So what existed before the accelerating expansion was a universe growing outwardly in two opposite directions. And due to the oncoming field lines, the part of the field that had already compressed was static. This means that we had a static and an expanding or growing universe at the same time. The field has an intrinsic expansion due to the elastic kinetic force of the quantum particle bouncing between lines, pushing the lines apart. And because there is an end to the field, the quantum particle can push the lines into empty space. This means that the field expands in all directions. The expansion of the field is not uniform. It will be different depending on the distance from the end of the field. If you're close to the end of the field, the universe is expanding faster than if you're closer to the middle. The Big Bang model says the age of the universe is 13.8 billion years. With my model, 13.8 billion would be 13.8 billion light years in distance. However, I believe that the field grew out to 17 billion light years, and that's where the last of the field lines collided, triggering the accelerating expansion. The first lines move off at the speed of light. The effect can only move through the field at the speed of light, so consecutive lines will move off at slower speeds. After 9.5 light years, the lines are moving at 1 meter per second. So what we do is to divide the speed of light by the distance divided by the speed of light. So we take the distance to the end of the field and divide it with the speed of light, and then we divide the speed of light with that. This will tell us how fast the expansion is where we are. But what is the distance to the end of the field? If we use general relativity via the Friedmann equations, and we are only interested in this part, 8 times pi times g divided by 3, we get 5.5878461 times 10 to minus 10. We then divide the speed of light with that, and we get 5.3650808 times 10 to 17. Then we multiply this by the speed of light, and we get 1.6084108 times 10 to 26. This then is divided by meters in a light year, and we get 17,430,825.5 light years in distance, and that many in years. This is showing a very slow expansion, and it needs to be slow. The reason for that is that all of the fundamental forces are governed by the distance between the lines. If the distance increases, then the forces weaken. These forces do weaken, but it's very slow over a long time. How fast is subject to speculation, but the rapid expansions had a velocity much faster than the speed of light. What these collisions and expansions create is vibrations in the field that travel the length of the field. These waves of energy may result in disturbing the formation of galaxies, and it may be that galaxies can't form until the field settles. The last collision would happen 17 billion light years away from us, so galaxy formation may have started along the length of the field at almost the same time. This could be why even the oldest stars in our galaxy have around the same age as the universe. This co-moving motion is to do with the bands that were formed due to the multiple collisions. This motion is in the two opposite directions the two fields came from. When the accelerating expansion begins, the bands are given a momentum with a direction that is orthogonal to the plane. Their momentum is due to the less dense part of the field between the bands. This is not an expansion of distance between the field lines, like the intrinsic expansion. It's a co-moving motion heading to the end of the field, so it's a faster movement than the intrinsic expansion. Over time, these bands dilute in formation. Dark flow or bulk flow is an observation that bulk galaxies are flowing in a certain direction. What has been observed is a coherent flow of galaxies with velocities of 600 to 1,000 kilometers per second in the direction of Centaurus and Hydra. This is the same direction the dipole anisotropy is showing Earth is moving in. The observation is that dark flow exists across the whole observable universe. The belief is that it's caused by something outside of the observable universe. Dark flow is the bulk directional co-moving motion, moving towards the end of the field that was set in motion once the last of the field lines collided. One of the consequences of the formed bands is that galaxies in an individual band will have the same redshift regardless of distance between them. The illustration shows Galaxy A further away from us than Galaxy B. According to the Big Bang Theory, Galaxy A should have a higher redshift. However, they are situated along the same plane perpendicular to their motion. Therefore, they are in the same band and they have the same redshift value. Galaxy C and D are in a different band, so they would have the same redshift, but it would be different from Galaxy A and B because they are closer to the end of the field. Now, over time, any rigid structure to these bands would dilute, mainly due to the large-scale structure of the universe that I will discuss later. Redshift quantization has been observed. What has been seen is that galaxies seem to clump together with certain values and skipping over other values. What is seen is a lot of galaxies with the same redshift separated by an area with very little to observe. My model gives us a reason for the existence of quantized redshift. Redshift of galaxies, according to the Big Bang theory, shows that all galaxies in the universe move away from all other galaxies, and that they were all once closer together. Redshift data is independent of any model, so it can be interpreted according to different models. If we align the redshift data with my model, we'll see that galaxies with higher redshift will be placed at the outer part of the universe, and progressively lower redshift heading towards where we are. So in my model, galaxies formed roughly where they are today. The James Webb Space Telescope has found massive mature galaxies that, according to the Big Bang theory, formed 500 million years after the Big Bang. This isn't enough time for these galaxies to form. My model says the universe expanded out to 17 billion light years, 4 billion past where these galaxies were found, so they had time to develop. However, we do see the majority of galaxies redshifted, which we have taken to indicate that everything is moving away from everything else. So what is really happening? This illustration shows Galaxy A, Earth, and Galaxy B in line, all moving in the same direction. Galaxy B is moving faster than Earth, so we see it redshifted. We are moving faster than Galaxy A, so light from Galaxy A is redshifted. A galaxy at the 120 degree mark is closer to the end of the field, so it will be moving faster than us and appear to be moving to the 180 degree point. It would also appear over time that a galaxy at the 60 degree mark will be moving towards the 0 degree mark. This is because we are moving away from it. So if we are not aware of this, then we will just think that everything is moving away from everything else. However, these galaxies are moving in the same direction. The universe formed from multiple consecutive collisions. One consequence of this is that consecutive background radiations were formed. Every time the field compressed, it would create a background radiation. So we are not seeing the first and one and only cosmic background, but a conglomerate of some of the last backgrounds. Is there any evidence for that? Sir Roger Penrose believes he has found concentric circular patterns in the cosmic background radiation. Each circle has a lower than average variation in temperature. The circular patterns are images of multiple backgrounds created along the length of the field. But why the temperature variations, and why are they circular? We need to understand that the microwave background wasn't created purely in the compressed bands. It was also created between the bands. However, the higher energy was with the bands, so they created more radiation, and less radiation was created between the bands. The collisions that create the light from the multiple backgrounds happens in a plane perpendicular to the direction of motion. So light coming from directly in front of us travels a shorter distance than light coming from an angle. So light from position A gets to us first. Light from position B, which comes from a higher energy band, will arrive before light from position A1. So this appears as circles. Light from the perpendicular plane comes to us as a cone. The peak reaches us first, and once that has passed, it turns into a circle, growing larger over time. Then the second peak will appear, and over time will also turn into a circle. When that one goes past, the next peak appears. The concentric circles Penrose has found does show a dot in the middle of the image. This is the beginning of the next cone. Once matter is created, protons and electrons will combine to form neutral atoms. However, we know that the intergalactic medium is ionized. In order to achieve this level of ionization, a very large source of photons had to be produced. This source of photons was created by the consecutive collisions that produced a high and consistent amount of radiation. So what we see here is that after the first collision, neutral atoms formed. Then later collisions created high amounts of radiation that moved into the part of the field where matter had become neutral, and reionized that matter. According to the Big Bang Theory, ionization started at redshift Z11 and was finished by redshift Z7, 150 to 1 billion years after the Big Bang. That means that there is low ionized matter between Z11 and Z7. It's mostly neutral matter. When you align this with my timeline, Z7, which is 12.8 billion, occurs before Z11, which is 13.8 billion. So in between these 2 points, it's mostly neutral matter, and up to 12.8, it's ionized. This tells us that the universe was reionizing up to just before 13.8, and then the source of ionization diminished. In my theory, the field got to 17 billion, where the last of the field lines collided, and the accelerated expansion started, reducing the production of ionizing radiation. There is a center to the universe. If we were in the center, the distance to the observable universe would be the same in every direction. The universe can be divided into two halves, so we are on one side or the other, not in the center. I know we're not in the center because we see a cosmic microwave background dipole. If we were in the center, we would not be moving, therefore no dipole. So what is the shape of the observable universe? Well, we'll need to make some assumptions. First, we'll put ourselves off-center and 13.8 billion light years from the end of the field. For the light from that distance to get to us, light from the central plane had to be coming to us for a longer time, because 13.8 billion would be formed well after the central plane was formed. Therefore, the shape of the observable universe in that direction is half an ellipsoid. From the opposite direction, it takes light longer to get to us. So, in the direct opposite direction, we would not be able to see as far as 13.8 billion. Therefore, the shape of the observable universe is a lopsided ellipsoid. So, the universe looks different in opposite directions. The fine structure constant has also been found to change over space and time. It's different on opposite sides of the universe. With the Big Bang Theory, this should not be happening. There shouldn't be a preferred direction in space. A change in fine structure hints to fundamental constants changing over time, and indeed they do. The reason for this is that in the inner part of the field, where the central plane is, the field lines are closer together, and due to the expanding field, the field lines in the outer part of the field are wider apart. This means that in the outer part, constants like gravity weaken, and in the inner part, gravity is stronger. First, the quadrupole and the octopole represent multiple cosmic backgrounds. They show hot regions separated by cold regions. As I said before, multiple backgrounds were created in alternating bands of higher and lower energy. Their correlation with the ecliptic plane is not specific to us. Every solar system in the universe will have an alignment to some degree. Any orientation of the ecliptic plane anywhere in the universe will separate regions. The alignment of the quadrupole and octopole, orthogonal to the ecliptic plane, is due to alternating hot and cold bands of light coming from above and below the plane. The biggest feature is a division by the ecliptic plane of a cold north and a hot south. This is a consequence of the angle the ecliptic plane has to the central plane. If we go back to the lopsided observable universe, the light coming to us from the other side of the central plane is travelling through a field that is not expanded as much as in the outer field. Therefore, that light is warmer, and light from the outer field is cooler. The direction of the axis of evil is in the same direction bulk flow is taking us in. It's the same direction of the cosmic microwave background dipole. It's the same direction the change in fine structure is in, and it's the direction of the expansion of the universe. Our universe is not just one field, but a conglomerate of fields ranging in sizes. So large fields would scoop up smaller fields to form a giant field. When this happens, the leading field lines penetrate each field. The lines can only penetrate a certain distance. This is due to the build-up of energy that prevents the two fields from completely merging. The area where the field lines have penetrated now has overlapping lines. This creates a greater energy density because the field lines are closer together, and this shortens the distance the quantum particle has to travel between lines. Multiple fields connecting this way create long filaments. The voids are the inner part of the fields where the lines are not overlapping, therefore the energy density is less. The overlapped areas, the filaments, have more energy density, and it is this reason that the majority of galaxies form in these areas. Where two fields join, more matter was created, and less matter in the non-overlapped areas. This creates a difference in temperature in different areas when cosmic background radiations were created. So this becomes the primary anisotropy temperature fluctuations in the heat map. We see areas where fields have overlapped with higher temperatures and voids with lower temperatures. I'm only going to talk about two types, elliptical and spiral. Let's imagine an overlapped area of field before any galaxy formation. The extra energy in this area will try to push the field lines further apart. As I explained in part 3, the field is a composition of three fields, each field responsible for the three fundamental forces. The orientation of the electric and magnetic lines are at a 45-degree angle. So as the extra energy in this area pushes the lines, a vast spheroidal shape is formed by the angled electric and magnetic lines. So prior to the visible development of an elliptical galaxy, a substructure exists. Elliptical galaxies are quieter, less energetic than spiral galaxies. What this says is that when two small fields collided to form this substructure, it may have been a slow speed collision. A high speed collision may have formed the substructure for a spiral galaxy. A more violent collision will emulate the field lines being compressed when the universe started. So a band of more dense field lines is formed. Along this band, the spiral arms or spiral galaxies form. Black holes are not portals to different dimensions. They are not infinitely dense, and they do have cores. Stellar black holes are stars with enough mass to collapse to a black hole. This collapse is extremely rapid, and it's this speed that extends the event horizon. So what exactly is an event horizon? All gravitational objects have an event horizon, and usually objects pass through with no problems. But a black hole event horizon is different. As the collapse occurs, the field is pulled in so fast that a gap between field lines is formed that is too wide for the lines to stay attached to particles. So anything entering the event horizon disintegrates back to quantum particles. Quantum particles are not affected by gravity, so they are not pushed to the core by gravity. However, fast rotating black holes will drag the field with it, as all rotating gravitational objects do. This is Einstein's frame dragging. But the field can only be dragged by a certain amount until it springs back, releasing enormous energy. A fast rotating black hole, by dragging its field, shuts off its event horizon, effectively creating a barrier, so nothing can get in. This creates an accretion disk around the black hole, so nothing enters a black hole, and therefore the black hole does not grow. So if the event horizon is shut down, what actually destroys anything getting too close? Well, it's the speed of the rotation of the black hole, not the black hole itself. The fast rotation stretches matter to the breaking point. So stellar black holes do not grow. So how do supermassive black holes form? Let's go back to galaxy formation. When two fields collide and create an overlapping of field lines, a high density area, a light year in diameter, is created in the center. This extra density would begin to push the lines apart and would expand the center of the field out very quickly. This creates a large central area of low energy, a low volume of quantum particles, and the sphere surrounding it of high energy density. This then collapses very quickly to form a huge central mass of purely quantum particles at the core. This becomes a massive black hole. These black holes form before stars form and could be essential for galaxy formation. In galaxy formation, I talked about how elliptical and spiral galaxies form in a pre-existing substructure of higher energy. This extra energy comes from the electric and magnetic fields, but more specifically, the magnetic field. The substructure in itself does not create a magnetic field. We need things like stars and black holes. But once they are present, the magnetic field dominates over large distances. Gravity at the solar system level dominates mass. However, by a certain distance from the core of a galaxy, it's the magnetic field that takes over, and it's this field that gives stars a high and flat rotation. So a simple analogy is a magnetic field produced by an electric field in a wire. We see that the magnetic field is circular with a direction. For a spiral galaxy, we need something to create a very large electric field in order for a very large circular magnetic field to form, and that's where Fermi bubbles come in. They are large structures above and below the galactic center, spanning 50,000 light years, emitting high energy gamma rays. This is only possible through the electric field. The electric field lines in the substructure are more compacted, and they are perpendicular to the magnetic field lines. So in the center where the primordial black hole is, there is a compacted electric field substructure, orthogonal to the compacted magnetic field substructure. And this is where Fermi bubbles are created. So a massive electric field exists above and below the center of the galaxy, and it's this that generates the circular magnetic field that stars orbit in. Spiral galaxies have bars extending out from their center. Here, stars have formed a three-dimensional bar structure. This is not a gravitational effect. This is a magnetic effect. It's like a giant bar magnet. Orbiting objects should be the domain of gravity. If we reform Newton's equation for orbiting objects, the square root of g times m divided by r, and throw in the speed of light from general relativity, it can be written this way: 4.3 times 10 to minus 7 divided by the radius times the speed of light times mass. 4.3 times 10 to minus 7 is close to my magnetic constant, 1 times 10 to minus 7. Both ways yield the same result. When gravity distorts the field, it also distorts the magnetic field. So the magnetic field becomes a part of gravity. So stars are orbiting in circular magnetic channels that are independent of the distance they are to the center of the galaxy. And the reason for this is that the magnetic field is essentially flattened out by the high-density band that was created when the substructure was formed. The cosmic cold spot is an unusually large and low-temperature area seen in the cosmic background. This may be due to the existence of a very large field which would create a large void. So when the lines compressed in this area, much less matter and radiation was created. So this would show in the primary anisotropy. However, there could be another explanation, and that could be that we are witnessing the end of the universe. When the last of the field lines collide with the field begins to accelerate into space. Matter as we know it disintegrates back to quantaparticles. This will create a large hole at the end of the universe that would appear as a hole or a spot in the cosmic background. Over time, this would get bigger. This brings us to another possibility, holes in the universe. It could be possible that where fields have joined, gaps could exist between them. Three fields merging could leave a gap. So there could be parts of the universe where there is no field. Anything entering this will disintegrate. These holes do not have gravity, and light cannot pass through them. Before the collision of two fields that form the particles we are familiar with, the field was only occupied by quantaparticles. Due to the field structure, the energy in the field, the quantaparticles, was equalized. This is a highly organized state. That would mean that entropy was low. However, quantaparticles are moving randomly, meaning they were in a disordered state, a high entropy. So at the same time, it had high and low entropy. When the two fields collided to form particles we are familiar with, some quantaparticles were encapsulated to form these particles. This means that entropy in the universe became distinguishable. So now there is low entropy moving to higher entropy. Eventually, due to the expansion of the field, the universe will transcend back to a pre-entropy, where we had order and disorder at the same time. So why is entropy one way? Why is the universe low entropy moving to higher entropy? To put it simply, things can't work unless they have low entropy. Atoms to molecules to stars and planets. If we were in the exact center of the universe, then our position in the universe would be static. The expansion would be equal in all directions. So everything would be redshifted, moving away from us at faster speeds the further away they are from us. This sounds like the Big Bang Theory. Big Bang theorists say there is no center and that it happened everywhere. In my theory, the initial collision was along a plane, so it wasn't just one spot. And there were multiple collisions after the first one, running perpendicular to the first one. This could be seen as the universe starting everywhere if you discount time. Part of the Big Bang Theory is inflation. The Big Bang describes how the universe expanded from an initial high density. In my theory, when the two fields collided, the field lines and the quantaparticles were pushed together, which created high density and extreme energy that pushed the field lines back at a speed faster than the speed of light, expanding that area. With the Big Bang Planck epoch, all of the fundamental forces were united. In my theory, when the field is pushed together, the three fields that are responsible for these forces are pushed together as though they are unified.